PowerMill 14 now supports fixture offset output for individual toolpaths within an NC program. By fixture offsets we mean, for example, G54, G55, G56, etc. So let's have a look at how we would go about outputting this fixture offset for this example project. So on the table of the machine we have a fixture. In that fixture we have two sets of impressions. We have a top and a bottom, and then the second set in its exact copy simply moved across by an X distance of 452 millimeters. So the first set is going to be machined using the G54 fixture offset, and the second set is going to be machined using the G55 fixture offset, all within the same NC program. So the first thing we need to do is create an NC program and then place our toolpaths within that NC program. So I'm just going to output the roughing toolpaths for this example. So we have rough top, which if I just draw that you can see roughs out the top of the first impression, and then we have rough bottom. If I just drag that one into my NC program, that roughs the bottom of the first impression. So this roughing toolpath for the top and the bottom now needs to be moved across or machined in a different position for the second set. So we need to make duplicate copies of those two toolpaths within the NC program. So we simply drag the toolpath in there again for the top and the bottom. So here we have rough top that appears twice and rough bottom that appears twice. So this is the first difference between earlier version of PowerMill, when we were not allowed to have the same toolpath more than once in a single NC program. But at the moment those toolpaths are on top of each other. We need to shift them across to machine the second set of impressions. Now this is going to be achieved using a fixture offset on the machine control, and the fixture offset will have an X shift of 452 millimeters. So to initiate that fixture offset we need to specify it within the NC program. So here you can see we have our new fixture offset option. At the moment there are no fixture offsets defined, so I'm going to go to my fixture offset list and create two fixture offsets, a G54 and a G55. And I'm going to put some values in there. At the moment just leave those at 0. Now I simply come back and select the toolpath and specify which fixture offset is being used for that individual toolpath. So the first one is going to be G54 and the second one is going to be G55. So G55 for the second set of impressions. So we can view the fixture offsets for each individual toolpath. So now we would simply post-process the NC program, and those fixture offset parameters would be picked up by the post-processing engine, and the relevant fixture offset commands would be put into the NC program. Now the new fixture offset functionality only works with the current Delcam post-processor. It does not work with the old legacy duct post-processor. Also, it is likely that your existing PMOpt file or PMOpz file, option file, will need to be modified so that it looks for and picks up the fixture offset parameters in the CL data. Now typically the fixture offsets in X, Y and Z are actually stored on the datum table on the machine control, so we don't have to provide those within PowerMill. But if we want to visualize the fixture offset in PowerMill, we can do that by using the fixture offset list and putting values into our XYZ. So we know that the G55 has a fixture offset of 452 in X. If I close that and draw my NC program, you can see, oops, let me just go back to this one, this third one, and change that to G55. There we go. So there we can see we can visualize the fixture offset in PowerMill. As well as visualize it, we can also use the machine simulation and the view mill simulation, and it will simulate in the correct position, showing the fixture offset. Typically the values in here are not exported to the NC program because those values are stored on the machine control in the data table, but these can be made to be exported if required. So now we can visualize the fixture offset within the NC program. We can simply come in and maybe do a machine simulation and do a collision checking with a machine tool to make sure there are no collisions.